Yo, what's up everyone? Patrick here, welcome back. And in this next video, we got to simplify these rational expressions that are adding and subtracting. So starting with number one, we got 2x plus 1 over x minus y plus 5x squared plus 5xy over x squared minus y squared. So first step, you want to factor. See if anything factors. Notice here, 2x plus 1, x minus y. Those don't factor, so let me just actually rewrite that here. But here, in this expression, a lot of stuff's going to factor. Notice we could take out a 5x up top, so we'd be left with x plus y then. And then notice x squared minus y squared, that's a difference of squares, like that. So a bunch of stuff factored over here. And then from this point, what you want to do after you factored everything is get restrictions before simplifying anything. So notice that here, x minus y cannot equal 0. So you could isolate for the y or the x. I'm going to isolate for the x. So basically x cannot equal y. And then notice here, this same factor, that would give the same restriction. And then this x plus y cannot equal 0, which means x cannot equal negative y. So those are the two restrictions, or x cannot equal plus or minus y. That's another way to write it. So those are the two restrictions, and now we factored, got the restrictions, now we could simplify. Notice in this case what's actually nice is that this and this cancel out. So this actually ends up being an easier addition because we would end up with this. And what's nice is after canceling these two, we have the same denominator. So we don't have to worry about getting a lowest common denominator. We can just add these two terms. 2x plus 1 plus 5x. The 2x and the 5x are like terms. So we would end up with 7x plus 1 over x minus y. You want to check in anything factor here. Nothing in the numerator or denominator can factor further. So that ends up being the final answer. Right? This is not always going to happen. Most cases it's not going to happen where stuff like this cancels. But sometimes it may, and if it does, it's just nicer because we have less factors to work with in the denominators. Now, if the x minus y canceled out, let's say this was x minus y, then x plus y, x minus y, those would be different factors. Then we'd have to multiply those, get a lowest common denominator because they're different factors. But because these ended up being the same factor, same denominator, we can just go ahead and add. Another thing I want to mention is, let's say this x plus y was like over here. Because this is adding, this and this aren't going to cancel out like they did when we were multiplying. When we were multiplying, they canceled out. But if there's a factor here, x plus y, factor here, x plus y, because there's that addition or subtraction in the middle, you can't just cancel out like that. In this case, they were able to cancel because this is one term. Over here, they're two separate terms. So I want to point that out as well. So after you do all this, this ends up being the final simplified answer for number one. And then those are the two restrictions. And then finally, number two, we got 3x plus 1 over x minus 1 minus x minus 1 over x minus 3 plus x plus 1 over x squared minus 4x plus 3. So first step, factor. Notice nothing factors in these two terms, so let's rewrite them as they are. But notice that in this last term, this denominator is going to factor. And that denominator, that's going to factor into x minus 3, x minus 1. Like that. All right, and then notice nothing would cancel out over here. Okay, so we factored everything. Now, we want to get the restrictions at this point. So notice x minus 1 cannot equal 0, which means x cannot equal 1. That's one of the restrictions. X minus 3 cannot equal 0, which means x cannot equal 3. And then these two factors, they also show up over here, and we dealt with those two over there. So the restrictions here, x cannot equal 3, x cannot equal 1. Those same restrictions apply to this denominator as well. And now from here, what we do is we simplify. Notice that we're subtracting, adding fractions, so we need a lowest common denominator. Now, what's the lowest common denominator between x minus 1, x minus 3, and then x minus 3 times x minus 1? Well, it's just going to be this term. Because notice x minus 3 goes into this x minus 1 times. And then notice x minus 1 goes into this x minus 3 times. Right? So the lowest common denominator is this. So when you have factors that are repeating, then you just have to write that factor once. We wouldn't multiply these two, so there wouldn't be like an x minus 3 squared. You can actually do that, but then the simplification after is going to be crazy. Right? So this is an example of where getting that correct lowest common denominator is really crucial, because there's already going to be a lot of algebra with getting the proper lowest common denominator. If you start adding factors, like instead of x minus 3, if you had an x minus 3 squared there, foiling all that out, it's just going to be a way bigger headache. Right? So getting that lowest common denominator is pretty crucial. So at this point, we got x minus 3, x minus 1, and then let's actually write everything out just so we could clearly see what is going on. Right, these two multiplied minus these two multiplied, it's just x minus 1 to the power 2, and then we're just adding that right there. So all of this turns into this. And now from here, what we got to do is simplify everything. So we would FOIL out these two brackets. We would end up with 3x squared minus 9x plus x gives us minus 8x minus 3. And then minus, when we FOIL out these two, we're going to subtract this whole expression after we FOIL it out, which would be x squared minus 2x plus 1. And then we got the plus x plus 1. All over x minus 3, x minus 1, like that. And then what I'm going to do, I'm actually going to continue this up here. So if we simplify everything, this negative, we're going to have to distribute 3x squared minus x squared would be 2x squared minus 8x plus 2x plus x. Right, this negative turn into a positive. So minus 8x plus 2x gives us negative 6x plus x gives us minus 5x. And then minus 3, minus 1, minus 4 plus 1 gives us minus 3. Like that. Right, so I skipped a lot of steps there. I don't recommend doing that for you. I would actually distribute, keep writing it out. But in this case, just to save some room on the whiteboard, I just simplified it into one step. I'm just checking my work now, making sure it's all good. And it looks all good to me. Yeah. Right, so this numerator is going to simplify to this, and then this is going to be all over x minus 3 times x minus 1. Now, are we done at this point? No. We're not, because you want to see if anything still factors even after you simplified. So notice that this numerator, it actually does factor. 2 times negative 3 is negative 6. Then we have a negative 5. What two numbers multiply to negative 6 add up to negative 5? That would be negative 6 and positive 1. Right? So this, we would simplify. We would decompose a negative 5x into these two. So now factor out a 2x, factor out a 1, and then we could factor out an x minus 3, and we're left with a 2x plus 1. So check this out. This numerator factors into that, And notice what happens in this case. This and that cancel out. The x minus 3's cancel out. And so we're left with 2x plus 1 over x minus 1. So that actually ends up being the final answer. And those are the two restrictions. So if we didn't factor this, right, we wouldn't have noticed that these cancel out. And there was no steps before that where we could have seen that these are going to cancel out. Right? So it's only factoring that simplified expression at the end where we were able to factor these or cancel these out and then further simplify. So this is the correct answer. This is more simplified than that. You might get part marks to get up to this point, but to get full marks, you'd have to get up to this point. So this is an example of where it's really important to factor at the end, again, seeing if anything cancels out. So this is the final answer. Those are the two restrictions.